Hello, my name is Larilyn Maligdong, and today we will be discussing experimental research. Experimental research. Experimental research is used in only about 8% to 10% of laboratory for experimental studies or LIS studies, according to a review of the literature. Causality. An understanding of causality is essential to the proper testing of hypotheses or relationships and is useful in designing research studies to be as rigorous as possible. In the social sciences, at least, the focus is typically on a variety of determining factors, which increase the probability of a certain event occurring. The conditions for causality. In the social sciences, a variety of factors tend to cause or influence any one dependent variable. A condition may or may not be both necessary and sufficient for the occurrence of a phenomenon. Basis for inferring causal relationships. It is impossible to prove that one variable causes another variable, either by itself or in combination with other variables. As a result, researchers normally have to infer a causal relationship between two or more variables based on the data gathered. Controlling the variables. Experimental research necessitates the control and manipulation of certain variables. True experimental manipulation also requires the use of at least one experimental group and one comparison or control group. Random assignment. The third and best technique for equating two or more groups before the experimental treatment begins is referred to as random assignment or randomization. Specific techniques used for random assignment are often essentially the same as those used for selecting random samples. Internal validity. The greater the control the experimenter has over the experimental variables, the greater the internal validity, the more artificial or unnatural is the setting, the lower the external validity. Threats to internal validity. Internal validity is crucial to the dependability of the results of an experiment, and it is closely related to replicability. It indicates the extent to which the experiment adequately tested the treatment under study by helping to rule out rival explanations and ensuring freedom from bias. Unfortunately, a number of factors can jeopardize the internal validity of experimental research. Those factors most frequently cited in standard texts are as follows: 1. History, or specific events, in addition to the experimental treatment or variable, which occur between measurements of the dependent variable. 2. Maturation, or processes within the subjects operating as a function of time, such as growing older or more mature. 3. Testing, or the effects of taking a test upon the scores of a subsequent testing. 4. Instrumentation, or the process wherein changes in the techniques used for the measurements, or changes in the persons making the measurements. 5. Statistical regression, or the statistical phenomenon wherein extreme scores obtained on a first test tend to gravitate toward the mean on subsequent tests. 6. Biases in differential selection of subjects for the comparison groups. 7. Experimental mortality, or the differential loss of subjects from the comparison group. 8. Interaction of selection and other sources of invalidity. The results of interaction can be mistaken for the effects of the experimental variable. External validity. External validity is important because it relates to the possibility that conclusions drawn from experimental results may not be generalizable to the real world. Threats to external validity. The major factors jeopardizing external validity or representativeness are as follows: 1. The reactive or interactive effect of testing. This occurs when a pretest increases or decreases the subject's sensitivity or responsiveness to the experimental variable, and thus makes the results unrepresentative of the general, or unpretested, population from which the subjects were selected. 2. The interaction effects of selection biases and the experimental variable. This threat is similar to the sixth listed threat to internal validity. It simply means that one must be careful not to select experimental subjects who are likely to be more receptive to the experimental variable than is the general population. 3. The reactive effects of the experimental arrangements can prevent the researcher from being able to generalize about the effect of the experimental variable on persons exposed to it in non-experimental settings. In other words, the experimental environment, or elements thereof, might have been influencing the subject along with, or instead of, the experimental treatment. 4. Multiple treatment interference may occur whenever more than one experimental treatment is applied to the same subjects, basically because the effects of prior treatments do not entirely disappear. In summary, the threats to external validity are basically interaction effects involving the experimental treatment and some other variable. On the other hand, the factors jeopardizing internal validity are those that directly affect the dependent variables or scores. They are factors which by themselves can produce changes which might be mistaken for the results of the experimental treatment. Experimental designs. Experimental research holds significant potential for the resolution of library-related problems. Survey research methods are not able to provide the researcher with enough control over extraneous variables. True experimental designs. 1. The pretest post-test control group design. One of the classic, true experimental designs is usually referred to as the pretest post-test control group design. The standard names of basic designs tend to describe them rather well, but diagrams point out their major features even more clearly. The diagram for this design appears as follows. 2. The Solomon 4 group design. A second standard, true experimental design is referred to as the Solomon 4 group design. It is diagrammed as follows. 3. The post-test only control group design. The post-test only control group design diagrams the same as the last two groups of the Solomon 4 group design and appears as follows. 4. Factorial designs. Factorial designs can deal with two or more independent variables and one dependent variable. They tend to be more valuable in external validity than other true experimental designs. As can be seen in the following example, a factorial design contains every possible combination of the independent variables. A simpler factorial design is as follows. True experiments and correlational studies. Essentially, true experiments can be conducted in real-life settings, assumingly the controls are adequate. Such experiments are often referred to as field experiments. Difficulties to be avoided. In order to design an experiment that will be as reliable and valid as possible, the researcher should attempt to avoid the following. 1. Relying too heavily on a single experiment. 2. Using poorly designed or faulty data collection instruments. 3. Not identifying all of the variables that may affect the results. 4. Not choosing subjects that are as representative of the population as possible. 5. Introducing experimenter bias. 6. Introducing subject bias. 7. Making the subjects aware of the hypothesis being tested through unconscious signaling or behavior. 8. Using an insufficient number of subjects. Evaluating the experiment. An experiment should be sensitive, that is, it should be able to detect relatively small effects or differences. Increasing the number of subjects and exerting additional control can help to increase sensitivity. Pre-experimental designs. Pre-experimental designs, which will be considered first, are those designs which not only lack random assignment but which have few observation points as well. A few examples of pre-experimental designs follow. 1. The one-shot case study. The one-shot case study, which can be diagrammed simply as XO, is an extremely weak design. As there is only one group, there is no basis for comparison of subjects who have received and have not received the experimental treatment. 2. The one-group pretest post-test design. The one-group pretest post-test design represents a slight improvement over the one-shot case study because it incorporates a pretest, or one more observation point. It appears as follows. 3. The static group comparison. Another pre-experimental design, which improves a bit more on the preceding designs, known as the static group comparison, diagrams as follows. Quasi-experimental designs. Quasi-experimental designs also have less control but are able to rule out more threats to internal validity than true experiments because they do not have randomly assigned treatment and comparison groups. A few examples of quasi-experimental designs follow. 1. The time series design. The time series design is an example of a single-group quasi-experimental design. It takes this form. 2. The equivalent time samples design. A second single-group quasi-experimental design, the equivalent time samples design, employs two equivalent measurements, one when the experimental variable is present and another when it is not, and then repeats the sequence. This design diagrams as follows. 3. The pretest post-test non-equivalent control group design. Multiple group design has some of the features of the static group comparison and the one-group pretest post-test design. As can be seen from the following diagram, it provides pretest information and a comparison group, but the groups are not fully matched or randomly assigned and thus cannot be assumed to be equivalent. 4. The multiple time series design. A second multiple group, quasi-experimental design is the multiple time series design. It is the multiple group counterpart of the time series design and could be diagrammed thus. Ex post facto designs. Ex post facto designs represent a weaker type of quasi-experimental design. They are designed to simulate real experimentation by using a static group type comparison such as web-based experiments. Web-based or internet-based experiments allow researchers to collect large amounts of data from widely dispersed people and locations at a relatively low cost. But they have relatively weak internal controls and thus are not well suited for the conduct of true experiments. Summary. Experimental studies have been criticized for being artificial and for not reflecting real-life situations. The quasi-experimental design is a compromise between pre-experiments and true experiments, which are high in internal validity but low in external validity.